Well, saw your question on the discussion board. Your question really wasn't with Part A, but we can go ahead and look at it. You receive a brochure from a large university. The brochure indicates the mean class size for full-time students is fewer than 32. You want to test this claim. And so you randomly select some students here. Can you support the claim? So the claim is fewer than 32 students. And so the alternative hypothesis is the mean is less than 32, which means the null hypothesis will be is mu greater than or equal to 32. So this would be the choice for the null and alternative hypothesis. Your question's about Part D, though. When do you know? When do you know if you have enough information to support the claim or not? So they offer two ways of doing that: the classical and the p-value approach. I prefer the p-value approach. So with the p-value approach, you compare p and alpha. Okay, you don't have to determine p-value. They give us alpha. You don't have to determine p-value from the data here in our hypothesis. And if p is less than alpha, then we're going to reject the null hypothesis. If p is not less than alpha, then we do not reject the null hypothesis. So you compare p and alpha, and if p, the probability of it happening, this sample data, if it's smaller than alpha, which is 5%, then we're going to reject the null hypothesis, and it'll support our claim, which is the alternative. If it's not p's not less than alpha, we're not going to reject the null hypothesis. We do not have sufficient evidence to support the claim that they're making. You can also use the critical value and the test statistic and compare. Look at those. But p-value approach is a little bit easier. Hope this helps.